Part 2 is on reasoning with properties from geometry. So last time we talked about reflexive property, symmetric property, and transitive property, but we just talked about just plain numbers. So if you remember reflexive property, we said, oh, that's when A is equal to A, right? So if I saw 7 equals 7, we're like, oh, reflexive property. What was symmetric? Do you guys remember symmetric? It's an if-then statement. So if A equals B, then B equals A. You can switch them around, right? So that was the symmetric property. And then transitive said something like, if A is equal to B, but B is also equal to C, then A transitions through B to get to C. So A is equal to C. Does that make sense? Okay, so we're going to have the same thing, but now we're going to have things about segments and angles. So if I have a segment that is congruent to another segment, I'm going to say AB is congruent to AB. However, this is saying property of equality. So remember how I talked about segments are congruent, and so objects are congruent, measurements are equal. How do I write the measurement, the length from A to B? I don't put like a little m or anything. I do for angles, but not here. So I'm just going to write AB equals AB. Okay? So you could also see congruence. Like you could see that AB with a line over it is congruent to AB with a line over it, but that would be properties of congruence, we would say instead. So we would say reflexive property of congruence is AB, the object, is congruent to AB, the object. Okay, but when we see AB without a line over it, that's just the length of the line of that segment, okay? And we'll talk about that throughout geometry. I'll talk about that many, many times. All right, so symmetric property. It's an if-then statement. So I'm going to say if AB is equal to CD, then CD is equal to AB. And then the transitive property, so we're going to say if AB is equal to CD and CD is equal to EF, then AB is equal to EF. Does that make sense? So same idea with our angle measures. So if I'm talking about an angle measurement being equal to an angle measurement, I'm going to write it as measure of angle A is equal to measure of angle A. But if I wanted to talk about congruence, so the reflexive property of congruence is angle A, the object, is congruent to angle A. Okay, so like I was saying, the difference between equality and congruence would be those. Do you guys understand what I'm saying? It's kind of a weird. We're picky in geometry, very, very picky, because you have to write precise proofs, and we can't just assume things, right? All right, so symmetric. So we're going to say if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. And the transitive property is the last one, so we're going to say if the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A equals the measure of angle C. I know this is thrilling. This is the most exciting stuff we've ever done in geometry here today. All right, so question. You can write this in if you want to. What about if I have AB is equal to BA? This is a tricky one. A lot of my students, and even like the first time I did this, I like would get these confused. I used to say it was the symmetric property, but it's not really. What is it? It's actually the reflexive. It's exactly the same segment is congruent to itself. But remember, we can write segments in different orders, right? We can say AB is the same as BA. So that would be the reflexive property. So you know what I often write on the same, or on the proofs when I'm like, ooh, should I put reflexive property? I don't know what to put here. I'll often just write same segment, so I don't have to think reflexive versus symmetric. So I'll do that sometimes too for you guys. All right, so it says in the figure below, AC is equal to BD. Verify that AB is equal to CD. Write a reason for each step. Okay, so we're going to do some proofs today, and they're going to be a little bit weird at first, so don't freak out if you don't know how to do these. So we got this. All right, so we're saying that AC, this distance right here, is the same as BD. So let's do some markings to say that those are the same. So I'm going to put like a little tick mark on my little brace. Don't you guys love drawing the braces? Can you do that? So if those are the same, we want to be able to say that A, B, and CD are the same. So someone tell me with words, like what are we doing here? Why do these have to be the same? Explain it to me in words. Think about it with numbers even. Like what if I knew that this was 30 and this was 30 and I knew the whole thing was 40? Explain it to me with numbers. No one can do it. You're just ready for your long weekend, aren't you? All right. So basically, if you saw that the big one was 30 and the whole thing was 40, then how much is left over on the end? 10. Isn't that the same on both sides? So wouldn't those have to be the same? So we're going to do that, but we're not going to use any numbers. Okay? So we're going to say, starting out, what's always our easiest step given? What were we given? What were we told? AC equals BD. That's what we were given. How are we going from this step with the reflexive property in order to get to this step? What am I going to subtract from both sides of the equation? BC. Did you guys see that in step 3? We're subtracting BC from both sides. BC is equal to BC because we know it's the reflexive property. So we're able to subtract it from both sides by the subtraction property of equality. So sometimes you'll see textbooks put in this step where it's BC equals BC. Sometimes you'll see textbooks just go straight from step 1 to step 3. Do you guys see how we could just subtract the same thing from both sides, BC and BC, and that's the subtraction property of equality. That's fine. I could have subtracted anything from both sides. All right, tricky one. Let's test your knowledge of chapter 1. Let's see what it says. It says AB plus BC. AB plus BC is equal to AC, this whole distance. Why is that true? Ah, good job, guys. Yes, segment addition postulate. That's an important one. So we're saying, oh, this little piece plus the medium piece equals the total piece, right? 2 segments added together equals the whole segment. Okay, and let's think about where we're trying to get. We're trying to get to those little tiny pieces that AB is equal to CD. So what can I take from both of them? Well, I knew that AC and BD, let's circle them. Weren't they right here? Couldn't I take this AB plus BC and put it right there? Do we agree? Couldn't I take this and put it right here? What statement do I get then? Yep, AB plus BC equals BC plus CD. What did I do? I took something that was here, this AC, and I replaced it with AB plus BC. Substitution. Ah, yes, I used the word substitution, right? So I substituted. Substitution property of equality. And then our last step, AB is equal to CD. Well, what did I subtract from both sides? I subtracted this BC. Do you guys see it? When I subtract that out, I'm left with AB is equal to CD. Subtraction property of equality. Is that what I wanted? Ding, 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 we're done. So we showed that AB is equal to CD. That's your first geometry proof. On a scale of 1 to 10, where are you at right now? 10, feeling good about this. 5, like what just happened. 1, like I don't even know my name right now. We're at a 7. I can take a 7. I will take a 7 gladly. All right, so let's try it again. All right, measure of angle ABC is equal to the measure of angle DBE. So let's put some markings in. So ABC is this angle, and it is equal to DBE, this angle. The air conditioning sounds like a train is going to hit our school. Do you guys hear how loud that is? Yeah. It's really loud. All right, let's think about what we're trying to show. We're trying to show that ABD, so you don't have to draw this, but I'm going to draw it up here. Everybody look up here. ABD, we want to show that this is the same as CBE, this one. I know that all of you guys can explain in words what's happening here. How are we going to show that those two are the same? Grace, do you have an idea? I saw you kind of raise your hand, but you weren't really raising your hand, but I'm going to pretend you were.
Because ABC and DBE are the same, and ABD is like ABC added to CBD.
Good. You guys see where she's going with this? They're both adding that middle part that's the same, the CBD. We're adding it to both sides, right? So we're probably using something called the angle addition postulate, right? Okay, let's see what happens. So we're going to start with our given. Easy point on the test. Everybody should get this point. You'd be shocked every year. People miss this point. I'm like, seriously? It's the given. Right? So we go, number one, given. Got it. So then it says measure of CBD is equal to itself. Measure of CBD. What's that? Reflexive property, right? You can put up equal if you want. So then Grace explained what we're going to do. She said, well, I can probably just add that into both of those. So what if I add CBD to both of them? Then I would have the measure of ABC added to the measure of angle CBD. That's equal to the measure of DBE added to the measure of angle CBD. So all I did is I added the same thing on both sides of my original equation. So it's the addition property of equality. So how can I say that the measure of ABD, this whole thing, is ABC added to CBD? What's the reason for number 4? Isn't that just the angle addition postulate? Did it scare you because it was directly below as well? You can sometimes combine those into one. Like a lot of times I'll just put them in the same box. Like I would put the next one here as well. So what's the next one that we also need to use the angle addition postulate for? We need to say the measure of angle. So we just did ABD. We did this one. DBE. Yeah, we need this other one, DBE, added to the other thing, right? So we're going to say measure of angle. So let's look where we're trying to get ABD, CBE. So let's say CBE in that order is equal to the measure of angle CBD plus the measure of angle DBE. So our last step, we're at our last step. We're trying to prove that ABC is equal to DBE. Oops. ABD, I said it wrong, didn't I? ABD is equal to measure of angle CBE. Is that right? Anyone have a guess? Kushal, what do you think? Not quite. Okay, let's look for these keys in here. So we got this is right here, right? And we got this is right here. Well, where else did we have that? So this red one is equal to this, right? The red one is equal to this. The blue one is equal to this. Isn't that right here as well? So do we have red equals blue? How did we get there? We took this one and plugged it in here, and we took this one and plugged it in here. Sometimes it helps to highlight and stuff. So we did substitution, yeah, we substituted. A lot of times substitution is one of the last ones. Not always. Okay, does that make sense? All right, so let's try these ones where it's just identifying. This will probably, I probably won't put a lot of proofs on the test. Maybe one where I give you the pieces. Like I say, okay, you're going to use all of these statements and reasons on your test, and you have to put them in the correct spots. So I might do something like that. Eventually, we're going to have proofs that will be completely blank, but probably not for the Chapter 2 test. So later, but not now. But I might do these on the Chapter 2 test. So it says, use the given property to complete the statement. If 3x plus 7 equals 22, then 3x is equal to 15. Did we use the subtraction property of equality? Yeah. Reflexive property of congruence. AB is congruent to AB with a line on it. Substitution. So mn is equal to 30. Mn plus nq equals 45. So what am I going to do? I'm going to substitute 30 in for mn. Do you see it? So it's going to look like 30 plus nq equals 45. And then what would the next step on that proof be? nq equals 15, subtraction property of equality, right? Does that make sense? All right, so number 4, it says solve for x and y using the diagram on the right. Think about what properties you use for each step. So I'm not going to make you write down what each property is, but we're going to say them. Okay? So it says, hint, one of them is called the vertical angles theorem. So we want to solve for x and y. So looking at these angles, do you guys see how angle 1 and angle 4, those have to be the same as each other, right? Because they're vertical angles. They have to be congruent. So we're going to say that 5x plus 2y has to equal 2x plus y. That was by the vertical angles theorem. They are across from each other. We have an equation that has x and y. Do you guys remember way back when? Algebra 1 last year. I know you forget everything sometimes during the summer. I don't think you guys forgot everything though, right? Cam, do you remember this? When you have an equation that has x and y, can you solve it? What do you need? You need a second equation that has x and y, right? Can we get a second equation that has x and y? Yeah, so we can get it from angle 2 and angle 5, right? So we're going to say negative 6x has to equal y plus 15. So we have two equations with x and y. So we're going to use substitution or elimination. Some of you guys like elimination better. In this case, I'm just going to do substitution because look here. Do you guys see how this y is really easy to get by itself? If I subtract this 15 over, I get negative 6x minus 15 is equal to y. Couldn't I just substitute in for these y's? My thing with x's? That's what I'm going to do. So I'm going to say I have 5x. I probably should have simplified my equation first. Maybe we should simplify the equation first. What do you guys think? Might as well. All right, so let's say we simplify. We get 3x minus or plus y equals 0. I mean, that y is really easy to get by itself too. This really isn't that bad. Couldn't we say y is equal to negative 3x? Let's do that. So if y is equal to negative 3x and y is equal to negative 6x minus 15, what equation can I write? Yeah, exactly. I'm going to say negative 3x has to equal negative 6x minus 15. I add my 6x over and I get 3x equals negative 15. So x is equal to negative 5. Okay, that can be kind of a red flag in geometry. Sometimes we don't like negatives, because can we have like a negative angle measurement? Not really. You can in pre-calc. Did you know that? That's when things get really crazy, but it's not an angle measurement, is it right now? It's just an x value, so that's okay. So we're good. So let's find y. So y was equal to negative 3x, so y is equal to 15. And then you could check by finding each of the angles. So how about this table right here? I want you to find angle 1. So plug in x and y. Colin, your table is going to find angle 4. Put your phone away. This table is going to find angle 2. That's easy. And you guys are going to find angle 5. And let's see if they work out. What did we get for angle 1?
5.
Just 5? The number 5?
I just.
That seems weird. 30. Yeah, it is 5, isn't it? Yikes. Maybe I shouldn't have done this step. All right, 5. I stole this problem from someone else. They clearly didn't think about their drawing to scale, did they? All right, how about number y plus 15?
30.
30? Ugh, this is not pretty. All right. This shows you for sure that sometimes in geometry things are not drawn to scale, right? All right, negative 6x, 30. And 2x plus y? 5. So at least we have our vertical angles are congruent, though. So yeah, sometimes they don't draw, and they put this on the SAT too, not this problem, but they'll do things where they make all the angles look the same, and they're not the same, and they'll say things like, angles are not drawn to scale. Angles are clearly not drawn to scale in this problem, right? So, all right, what if I wanted to get 6 and 3? Well, I could just find 35. I could subtract from 180, right, and get the other measurement. All right, so is that the last one? I think that is, right?